This is the third part of section Geometry F of the Geometry module. In this section we're continuing to look at volume, and in this one we're looking at spheres. Now remembering that a sphere is just like a tennis ball, okay, or the earth. The volume of a sphere is calculated using 4/3 pi r cubed. Now half of a sphere is called a hemisphere. No need for a special formula, just work out the volume of a whole sphere and divide it by 2. So here we've got find the volume of the following figures. We have a sphere to start with, so volume is 4/3 pi r cubed, so that's 4/3 times pi times 35 cubed. Plug that in your calculator and you get approximately 179,594 centimetres cubed. Now if you're wondering about the whole decimal place thing, I do notice that in the textbook sometimes it's 1 decimal place, sometimes it's the nearest whole number, sometimes it's 2 decimal places. I usually just go to the 2 decimal places as a convention, okay, but as long as you put the approximate sign in. Now a hemisphere of diameter 12 centimetres, well first of all we need to work out the radius, which is 12 divided by 2, which is 6. So the volume is 4/3 pi r cubed, so 4/3 times pi times 6 cubed. Okay, now the other thing is it's a hemisphere, so all we're going to do is divide that by 2. Okay, whatever our answer is we'll divide by 2, and you end up getting approximately 452.4 centimetres cubed. Okay, remembering that approximate sign at the beginning. Here we have a composite solid. We have a cylinder at the bottom and the hemisphere at the top. So volume of the cylinder is pi r squared h. The radius is 3, so pi times 3 squared times by the height, which is 2. So plugging that on the calculator, I'm going to not worry about the pi anymore, so I'm just going to do the 3 squared times 2. So 9 times 2 is 18 pi. And I'm going to leave it like that until I get to my final answer, so I'm not approximating as much. It's not done like this in the textbook, but as you're moving into more advanced maths, it's good to find ways where you're only approximating at the end. Okay, so volume of the hemisphere is going to be 4/3 pi r cubed, and it's all going to be divided by 2. So 4/3 times pi times 3 cubed, all divided by 2. Okay, again, I'm not going to worry at the moment about that pi. So I've got 4 divided by 3, and then I'm going to times that by 3 cubed, which is 27, and I get 36 pi. That's divided by 2, which gives me 18 pi. So my volume of my total volume, is going to be 18 pi plus 18 pi. Notice that they're exactly the same volume, kind of cool, which is 36 pi. Then plug that into your calculator and you get, again I keep forgetting my approximate sign, approximately 113.10, and we're in meters cubed. Okay, so just remember the trick of leaving the pi until the end, so you're not dealing with decimals all the way through and you're not constantly approximating. Next, how much ice cream would fit in the solid shown, assuming that the cone was filled as well. So we're kind of talking about a cornetto but without a flat top. So we've got 2 shapes here. We've got a cone in the bottom and then we've got a hemisphere at the top. So volume of the cone is 1/3 times the area of the base times by the height, so 1/3 pi r squared h. Now it's giving me the diameter. The diameter equals 5, so the radius is going to be 5 divided by 2, which is 2.5. So come back, we've got 1/3 times pi times by 2.5 squared times by the height of my cone, which is 8. Okay, 2.5 squared times by 8 is 50 pi over 3. So I'm going to leave it like that. Now volume of the hemisphere, I need to know the height of the hemisphere, and that's just the radius, so it's 2.5. So volume is 4 over 3 pi r cubed, and then I'm going to divide it all by 2. So I've got 4 over 3 times pi times 2.5 cubed, and then that's all divided by 2. Okay, so 4 times 2.5 to the power of 3. And I can divide that by 3, and it won't work. So I'm going to leave it as 62.5 pi divided by 3, or divided by 2. That divided by 2 is 62.5 pi over 6. If it looks too technical leaving the pi there, then evaluate it yourself. I'm just trying to show you another way. So volume total is going to be the 50 pi over 3 plus 62.5 pi over 6. Now note, I would never answer mixing a decimal with a fraction. You should never do that, but it's a means to an end. This is leading to my final answer. Okay, so now I can plug all that into my calculator, and I'm only going to be approximating at this point. Okay, so this is the beauty of doing it like this. But again, if you think it's too confusing, then don't stress, do it the other way. Okay, and you get approximately 85.08, and we're in centimeters cubed. Okay, the textbook has it where it evaluates this and then evaluates that and then uses the decimals in the end. So have a look at that. Last example, a hemispherical bowl needs to hold 5 litres of fruit punch. What radius would the bowl need to have? Okay, so we're talking about a hemisphere. That's a bowl, and it holds 5 litres, so that's its volume, and I want to know what the radius is. Okay, well, 5 litres is the same as 5,000 millilitres, and we know that 1 milliliter is 1 centimetre cubed, so that's 5,000 centimetres cubed. Now my volume is 4 over 3 pi r cubed, and then that has to be divided by 2. So I've got 5,000 equals 4 over 3 pi times my radius, which I don't know, r cubed, all divided by 2. I'm going to get that divided by 2 out of the way first, so I'm going to divide both sides by 2. So now I have 10,000 equals 4 over 3 pi r cubed. I can get rid of that 3, so I'm going to times both sides by 3. So now I have 30,000 equals 4 pi r cubed. Now I'm going to get rid of the 4 pi, so I'm just going to divide both sides by 4 pi. Okay, so 30,000 divided by 4 times pi, I get approximately, so r cubed is approximately 2387.32. Now I'm going to use the answer on my calculator, and I'm going to cube root that. Okay, so I'm not approximating, I'm cube rooting exactly what's in my calculator, so therefore I'm not approximating twice. And I get that r is approximately 13.37 centimetres. Okay, so it's a worded question, so therefore bowl would need radius of approximately 13.37 centimetres. Okay, you could go to 14 centimetres, which is still going to hold all that punch. What now? Well, it's the last video, so complete the last exercise, which is Geometry F3. You should read the summary and revise, complete the review exercise in the chapter, and complete and submit the module test. Now, one thing that you should do between here and here that you're probably already thinking is the sample test. Always do the sample test and mark it to make sure you're on the right track. Good luck!